So once you divide, T is 741.1. So it will take 741, approximately 741.1 hours to break even. So 741 or 42. So that's the break-even number right there. Okay, so in 96 they talk about an apartment complex and that it has 50 units, and they rent it at different rates, and depending on the rate that it's being rented, that's how many units are occupied. So when they rent it at $580, all 50 units are occupied. But when they raise the rent to $625, on average 47 units are occupied. Okay, so they want you to write a linear equation. We're assuming that the relationship is linear, that's what it says there, and write an equation of the line giving the demand X in terms of the rent P. And that's why you see X in the second, like where you normally see the Y. You know how usually, because right now X isn't talking about the independent variable. Here they called X the demand, so the number of units that are being rented, and P is the rent, which is the amount at which they are being rented per month. So we have two ordered pairs. We have we can get a slope from this. So it's going to be 47 minus 50 over 625 minus 580. So that gives us negative 3 over 45, and which it reduces to negative 1 over 15. So this is the slope of this relationship, this relation. So from here we're going to write an equation. So you pick whichever point you want. I'll just pick this one right here. So let's see, 50 equals negative 1 over 15 times 580 plus B. So I'm going to multiply, or actually divide 15 into 580 to see what I get, and then add it to both sides of the equation. So when I used my calculator, I got negative 38.6, forever, 0.66 forever. So you know that when that is the case, it's actually 2/3. 0.6 never ending is 2/3. Okay, so I added 38 and 2/3 to both sides, and so that gave me B equals 88 and 2/3. So when I write my equation for this, it's X equals negative 1 over 15 P plus, now I'm going to write 88 and 2/3 as an improper fraction, so that's 266 over 3, because I multiplied 88 times 3 and then added 2. So here's the equation for part A, and then it says use a graphing calculator, but again we could skip that part and just go to estimate how many units would be occupied if they were rented at $655. So we're going to replace the P with 655 for part B. So X equals negative 1/15, 655, and then add it to 266 over 3. And just let your calculator do the rest of it here. Okay, so when you input this in the calculator, 655 divided by 15, and it's negative, and add it to this number here, which is actually 88 and 2/3. So you can add it as 88 and 2/3 or as 266 over 3. But the calculator will take care of all the converting it to decimal and all that. So you're going to end up with 45. So X equals 45. So 45 units will be occupied if the rent goes up to $655. Okay, And then for C, they want you to predict how many units would be occupied when the rent is lowered to $5.95. So same function or same equation, negative 1 over 15. Instead of $6.55, it's going to be $5.95 plus 266 over 3. And just let you know, plug this into the calculator. 595 divided by 15. Change the sign because it's negative, and then add 88 2/3. So if they lower the rent to $5.95, 49 of their units will be rented, will be occupied. Okay? Okay, so for 100, you have to say, for number 100, you have to say whether the statement is true or false. It says, if the points 10, negative 3, and 2, negative 9 lie on the same line, then the point negative 12, negative 37 halves also lies on that line. So we want to show whether this point right here lies on the line that is formed by connecting these 2 points right here. So we need to find the equation of this line first, okay, and see whether this point fits into that equation. So I need to find the slope formed, the slope we have, the slope for the line that goes through these 2 points. So m negative 9 minus negative 3, and then 2 minus 10. So then that gives me negative 9 plus 3, so that's negative 6 over negative 8, which is 3/4 when you reduce it. Pick whichever point you like. I'll just pick the first one. So negative 3 equals 3/4 times 10 plus b. So I get negative 3 equals 30 over 4. I can reduce it if I want to 15 over 2. So I'll make the number smaller, so 15 over 2. I'm going to subtract 15 over 2 from both sides. So I get negative 3 minus 15 over 2 equals b. So this negative 3 over 1 is going to become negative 6 over 2 minus 15 over 2. So b is negative 21 over 2. Okay, so the equation for this one is going to be y equals 3/4 x minus 21 halves. Okay, so here's the equation for this line. So does this point right here lie on this line? How do we find out? We substitute the numbers. So I know that x is 12, right? Negative 12, right? So I'm going to try that out. I'm going to see what y equals when x is negative 12. And so you reduce this into here. That's 9. 4 goes into 12 3 times, right? So 3 times negative 3 is negative 9. So negative 9 minus 21 halves. Again, I need a common denominator. So I get negative 18 halves minus 21 halves. So that gives me negative 39 halves. Well, unfortunately, the y value over here on this side is negative 37 halves. So this statement is false. Okay, so for the last 4 problems, they are review of factoring quadratics. I know that you have your own way, the way you learned the way you first learned it. You probably like that way, and you can continue using that method if it works. Okay? If your answers are coming out right, keep using it. I'm going to show you the box method, and again, if you like it, use it. If not, just use your own method as long as it works, right? So first thing we do is you multiply these two. So this gives us negative 27x squared. And then we bring down the x squared. We bring down the negative 27. And then we ask ourselves, okay, factors of negative 27 that add up to negative 6. So what are factors of negative 27 that add up to negative 6? So negative 9x and 3x. So these 4 terms right here go into a box. Just just put them in order, okay? So x squared, negative 9x, 3x, negative 27, and then you start factoring out greatest common factor. So starting with the first row, so starting with this one right here, what's the greatest common factor? X. Oops, X. And then you ask yourself, okay, something times x has to give me x squared. So that is x. Do the same thing on the next empty spot up here. Something times x has to give me negative 9x. Negative 9. And then something times x has to give me 3x. And that's 3. Oops, 3. And then as a final check, you always multiply the constant, so this number, and they have to give you this number right here. So it's 3 times negative 9, negative 27. The answer is yes. So that means that you factored it properly. Now, which ones are the factors? The ones on the outside. So this one and this one. Okay. 124. We have x squared plus 11x plus 28. So I mean, when the coefficient, the leading coefficient is 1, you don't have to go through this box method, but I like to do it anyway just to show you that that it works for all of them. So that's why I'm going through the steps. But basically, you multiply these two right here, 28x squared. You bring down the x squared, bring down the 28, and then you find factors of 28 that add up to 11. So that would make it 7x and 4x. Okay? So 7x and 4x add up to 11, and they multiply to give you 28x squared. So now you have your 4 terms right here. Those go in the box. And what I like to do is I usually just put the numbers, not the variables. So I'll put, like, for x squared, I'll put 1 because that's the coefficient of x squared. For 7x, I'll just put the 7. For 4x, I'll just put the 4. And then for 28, I'll put the 28, right, because that's the number. So the greatest common factor up here in this row is 1. And then 1 times this is going to give me 1. Well, 1 times 1 gives me 1. And then something times 1 is going to give me 7. Well, 7 times 1 gives me 7. And then something times 1 is going to give me 4. Well, that's 4. So how you read it in this problem is the 1 and the 7 basically just means x plus 7. And the 1 and the 4 means x plus 4. And that's your answer. Okay, and then for the next one, 125. Okay, now this is where the box method actually comes in more handy. The first two examples I could have done it without the box method. So 2x squared plus 11x minus 40. We multiply these two, we get negative 80x squared. Bring down the 2x squared. Bring down the negative 40. Oops, x squared right there. So we're looking for factors of negative 80 that add up to positive 11. So factors of negative 80 that add up to positive 11. So the factors are 16 and negative 5. So 16x minus 5x. So these two add up to 11x, and they multiply to negative 80x squared. So those are the ones we're going to use for our box. So I'll put in the x here, the x's. I mean, you don't have to, but 16x